Okay, this is the semester exam review for geometry in spring of 2018. This first page is Unit 7. It is the centers of the triangle. So if you will, go back and study this one. Centers of a triangle, that was the notes over this section. These will not be on the final exam. They are not going to be on the formula chart, so this is something you're going to have to need to know and learn. Okay, back to our semester exam review. The first three questions are about Unit 7. What is the length of XZ? Well, this line right here, WX, is my angle bisector. I can tell because it splits this angle in half. And I'm going to find the length of XZ. That's this one here. Well, what we know about the angle bisector is that any point along this line, like X, is equidistant to the side. That's why these perpendicular boxes are here. Okay, so those two pieces are equal. That means 7h minus 5 is equal to 3h plus 5. So I'm going to solve for h. I need to subtract 3h from both sides. I get 4h minus 5 equals 5. Need to get the negative 5 over with 5, so I'm going to add 5 to both sides. 4h is equal to 10. Divide that by 4, and h is going to equal 2.5. Now you do see 2.5 here, but I got to make sure I answer the question. What is the length of XZ? That doesn't answer that question, so I can eliminate it. XZ is 3h plus 5. Well, 3 times 2.5 plus 5. I need that h to find it. So 7.5 plus 5 is equal to 12.5, and that's the length of XZ, so it's really B. Number 2, what type of special segment is AI? Okay, here's AI right here. I'm looking at the segments piece here. I can see that these are an angle being bisected. Looking at my answer choices, I would think it would be the angle bisector, because as we discussed up here in number 1 as well, that was an angle bisector too. Number 3, and I had to move the screen up a little bit. What is the length of RO? Okay, RO is this entire length here. And we can see that all of these appear to be hitting the middle. So these are called medians. Okay, medians start from the vertex and hit the midpoint of the opposite side. Now RL is 10, so that 10 does go with RL. And the special property about medians is the length from L to O is 2/3. LO is 2/3 the entire length of the segment RO. Okay, so from the centroid out to the vertex, it is 2/3 the length. Well, if this piece is 2/3, then that means RL is 1/3. Okay, so RL is 1/3. And since it's 1/3 of RO, the entire length. Well, I already know what that one is. That one's 10. I know that's 1/3. So to get rid of 1/3, I would have to multiply by 3. That means my entire length is 30. And that's what they asked me to find, 30. So this answer is B. Now, also, if this is 1/3 and this is 2/3, then that makes LO 20. And then I can add 10 plus 20 to also get 30. Okay, number 4. we want to find the missing side in simplest radical form. So we're hitting two teeth at once. We're hitting Pythagorean Theorem because this is a right triangle, and I'm trying to find the missing side. And we're hitting the fact that we need to be able to simplify a radical. So for number 4, we're going to have a squared plus b squared equals c squared. And q is one of my sides, so it's going to be q squared plus 10 squared equals 12 squared. How do I know where to put my sides? Well, the two that make up the 90-degree angle here, those are my legs. That's A and B. And I know to put 12 in the C spot because it's always the longest side, and it's always across that 90-degree angle. So now I'm going to solve for q squared. Q squared plus 100, it's 10 squared, equals 12 squared is 144. Then I need to subtract 100. Q squared is equal to 44, and then I need to square root both sides. And now I'm going to take the square root of 44, and I'm going to simplify it, because I see 44, but I know it's under the square root, so that can't be it. And what I'm going to do is I'm going to simplify it, and I'm going to factor out the prime factors. So I always start with the lowest prime factor, that's 2, and 2 goes into an even number, so I get 22. And I want to divide that out as many times as I can. So 2 goes into 22, that's 11. Now I can't divide by 2, so my next prime number is 3. 3 doesn't go into 11. My next prime number is 5. 5 doesn't go into 11. My next one is 7. 7 doesn't go in, but the next one is 11. Then I get 1, and that's how I know I'm done. Now with the square root, I have to have at least 2 of them to make a whole. So I have 2 2's. That makes a whole number. So that gets to come outside and play outside of the radical. 11's all by itself. He doesn't have a partner. He has to stay inside. So that makes my final answer D, 2 square root of 11. Classify the triangles acute, right, or obtuse using the Pythagorean Theorem. Okay, a squared plus b squared equals c squared. I know 20 is my c side because it's the longest one. So I'm going to have 12 squared plus 16 squared equals 20 squared. Well, if it's equal, it's a right angle. Okay, if it's equal, it's right. If it's obtuse, the c squared is going to be greater. And if it's acute, the a plus b squared, a squared plus b squared is going to be greater. Okay, so I know 12 squared is 144, I know 16 squared is 256, and I know 20 squared is 400. And when I add that up, I do get 400 is equal to 400. Well, since they are equal, equal went with the right triangle, so I know it's A, it's right. Use special right triangles to find missing sides. Okay, well, I see a 45-degree angle here. So that means I'm going to be using my 45, 45, 90, and that will be on your formula chart. And I know the 45 sides have a ratio of x to x, and the hypotenuse, 90, has x square root of 2. And we made a table. Okay, and they tell me TO is 6. That is my hypotenuse. So I'm going to put 6 in my table underneath x square root of 2 because these two equal each other. X square root of 2 is going to equal 6. So that means I can solve for x. I can find x, and I got to divide by square root of 2. The only problem is square root of 2 is irrational, and I can't leave it in the denominator. So I'm going to take 6 square root of 2, and I'm going to get rid of the square root of 2. And all I have to do is multiply by the square root of 2 again. Okay? Because I need 2, like up here, I need 2 of them to make a whole. So I get 6 square root of 2 over, and because this is a square root and this is a square root, when I multiply them together, they become a whole number. So I get 6 square root of 2. Then I simplify it further because the 6 and the 2 can divide out, and I get 3 square root of 2. So that means my x's are 3 square root of 2. And that's what I found. I found that my x's are 3 square root of 2. So then I want to look at my answer choices, and I want to look for 2 3 square roots of 2 because that's going to be my answer. They have to be the same. And that's going to be A. Okay, number 7 says use special right triangles to find the missing side. Here, this one's 60, so that means I have a 30, 60, 90. And again, this will be on the formula chart. And I have the 30-degree side is x, the 60-degree side is x squared to 3, and the 90-degree side is 2x. And again, we make our table. And they tell me TB is 2. Okay, well, TB is across the 30-degree angle, so that's going to go under x, 2. Okay, well, that's easy because then I can just substitute in. Because 2 is x is equal to 2, then I can substitute that in here. So this is 2 square root of 3, and 2 times 2 is 4. So I know that AB should be 2 square root of 3, and AT should be 4. So I'm going to look for those, and there it is at A. Number 8, write trigonometric ratios for tangent y as a fraction and as a decimal rounded to the nearest hundredth. Okay, well, here's y. Y is going to be my theta. That's the angle I'm looking for. And tangent, and that should be on your, it's also on your formula chart. The tangent is equal to the opposite side over the adjacent side. Now, opposite and adjacent depend on where the theta is. Since theta is at y, directly across, that's going to be the opposite side. So 12 represents the opposite side. Adjacent to it, that's right next to it, that's 9. Now, 15 is the hypotenuse. It's always across that 90-degree angle. So that 15 would represent h. But tangent is opposite over adjacent. So I have the tangent of my theta, which is the angle. My opposite side I identified as 12, and my adjacent side I identified as 9. So I'm looking for 12 over 9, and I only see one of them. That's going to be A, and if I get the decimal, it's 1.33. Number 9, we're back to the Pythagorean Theorem. A squared plus B squared equals C squared. And I have 4 squared plus 8 squared equals x squared. And I know that x goes in the C spot because it's directly across the 90-degree angle. So I'm going to square those. 16 plus 64 equals x squared. I get 10. 80 equals x squared. And then I got to take the square root. Okay, so just like before, I'm going to take 80, take the square root, and I'm going to start dividing out by my smallest prime number. So I get 40. I'm going to divide by 2 again. I get 20. I'm going to divide by 2 again. I get 10. I'm going to keep dividing by 2 until I can't divide by 2 anymore, and I get to 5. 5 is a prime number, so I know 5 is going to go here. And there's my 1 and done. Now I need 2 to come outside. This is, every single one of these is to the half power. So I need 2 of them to make a whole. So this 2 gets to come out of the radical. This 2 gets to come out of the radical. When more than one number gets to come out, we multiply them together. 5 doesn't have a partner. It stays inside. So it's going to be 4 square root of 5. And that's going to be B. Now I know on your answer choice it says 3 square root of 5, and that's incorrect. It's going to be B. Okay, I'm going to stop this video here, and I'll continue with another video for the next set of problems.